Hello and welcome to this DCD talk on rack containment as a cooling strategy. I'm Emma Strutton, I'm Head of Channels at DCD, and I'm delighted to be joined today by Tom Demitras, who is the Chief Engineer at DDC Solutions. So thanks very much for joining me today, Tom. How are you?
I'm good, Emma. How are you this morning?
Yeah, very well, very well. Thank you for asking. So to start us off, are you able to tell me a bit more about you, your role at DDC Solutions, and your career journey so far?
Sure. So I've been at DDC Solutions for about 2 years now. Previously, I worked for a vendor of DDC Solutions. So I've worked directly 2 years, but been working with the product for going on 14 years now. Prior to that, I predominantly did just general racks and enclosures for data centers. So I've been in the space for quite a long period of time and been doing really high density cooling for the last couple of years.
That's great. Thanks so much, Tom. Yeah, you teed me up quite well, really, to talk around high density cooling and rack containment. So, obviously, traditionally, room level containment has been the standard approach for years. So, what is different about rack level containment, and why is it becoming such an important part of the conversation now?
Sure. So for years, obviously, we've done hot aisle, cold aisle, rather low density that worked quite well with either raised floor, drop ceilings. And historically, it was sort of 2 to 10 kilowatts. I've watched it go up over the course of my career, but every cabinet affected the cabinets adjacent to it. So you could have hot spots in a room, you could have cold spots in a room, or have to set the room temperature quite a bit lower just in order to manage those. And what DDC has done is taken that containment all the way down to the rack level, which subsequently lets each IT cabinet have the direct amount of cooling that it needs, not affecting the cabinets adjacent to it, not exchanging air with the room. And that lets you build out a data center in sort of steps rather than having to build out the whole thing. Historically, we ran CFD analysis on it, and you'd have to figure out where the floor tiles went. Now, if you're adding gear, you just put it in the cabinet that it needs to go in. The rack level containment solves the cooling solution with its own pair of coils and its own cooling fans, and it's not affecting the cabinets adjacent to it. It brings in a couple of other really big advantages from a safety standpoint. So it also allows you to do onboard fire suppression. It allows you to do things like NEMA 3R ratings. There's so much water in the data center nowadays that drips become important, and people have great ways of managing that with automatic shutoff valves, etc. But if you just have an umbrella over your IT gear at each cabinet level, sort of solves the problem for the room level. So lots of good things come in. It's not drastically different. It's just localizing the cooling down to, I don't want to say the bottom level because it can always change in the future, but sort of the closest you can get to an individual cabinet.
Yeah. Thank you, Tom. And when containment is done at the rack level, what does it change about how the data hall performs thermally? And, what does that mean for energy efficiency?
Sure. So with each individual IT cab only cooling the amount that it needs, we're not having to push air from A down the room and around the corner, but also allows each cabinet to increase or decrease the CFM of the fans or the flow of the chilled water. So your PUE starts to become more optimized rather than having to, say, run a air conditioner to cool your whole house. You don't do that for your refrigerator, right? You don't set your whole house to 32 degrees. You set your house to a comfortable level for us, and then you run the fridge at the appropriate level. And it's the same sort of idea where we're precision cooling rather than trying to cool the entire space to handle the lowest load.
Thanks very much, Tom. Yeah, that makes a lot of sense. And how far can you actually push airside cooling density with rack level containment in place? And what point does liquid cooling need to enter the picture?
So it's a function of the amount of space that's available in a rack compared to the heat that's put off by each rack unit of gear. Currently, what we're seeing is that nobody's really over 85 kilowatts worth of airside cooling. And that's predominantly driven by a 52 RMU rack. So the NVIDIAs and AMDs of the world are putting out gear, and there's only so much heat density that you can get in that space for airside cooling. So without going to a taller rack, that seems to be the practical limit today. And then once you hit the 85 kilowatt range, and get to liquid to the chip above that. But if you're in a restricted ceiling height room and you've only got 42U worth of rack space to work with, that number is lower. And if you're to go to a 60U rack, which is very difficult to ship via trucking companies, that number could go up. Practically speaking, the highest we've seen shipped is 111 kilowatts per rack of airside cooling only. That was in a very tall cabinet. So the sky's really the limit. It's more of a space versus power constraint than it is what can you do.
Yeah, that makes sense. And of course, one thing that we're hearing about and a lot in the data center industry is kind of how quickly technology is evolving, tech refresh cycles, and operators, of course, worry about infrastructure decisions that don't age well. So how does rack level containment hold up as workloads and hardware keep changing?
I think it's a really good solution for that. There's a specific way that we're addressing that helps be more forward looking. Sales guys might say future proof. That's a scary word because I don't know what's happening a couple years out from now. But DDC's rack solution has a roll in option where you can roll in an IT rack of standard sizing. Most of the major manufacturers are making this. And then when the gear changes, as the gear changes down the road, you're unbolting that rack, rolling it out, rolling the next one in. So we're facilitating all of the airside cooling and then connection points for power, connection points for the liquid side of the cooling at a very, very expedient changeover. One of the best stories, and I'll keep it brief, but we had a customer that needed to change cabinets, and they were just changing position. They weren't getting new gear, but they had to change cabinets where they had some low kilowatt cabinets, and they had to move them to a position where there was high kilowatt cabinets. And they moved sort of 8 of them in a morning rather than having to deconstruct a hack and then move the cabinets and then reconstruct the hack, which historically would have taken 3 to 5 days. They were doing it in a half of a day, and the customer was thrilled with it, obviously. So we're thrilled with the success story too.
Yeah, great story. And I suppose for operators who are evaluating rack level containment today, whether for a new build or a retrofit, where would you tell them to start?
A couple of options there. So new build tends to have higher ceiling heights. There's so much equipment, MEP and electrical equipment going overhead nowadays that people are building rooms taller, data halls taller. So it's a good spot to start with our S4, S5 series that tend to be quite tall where the cooling unit is on top. If there's a retrofit build, sometimes the ceiling heights are quite a bit lower. Historically, we didn't need that space. So we have the GPU vault, which moves the cooling unit to the side rather than placing it on the top, and that lets you fit within a restricted ceiling height. And then even on top of that, we're just coming out with a very short unit for sort of office buildings in large cities where not only do I have a restricted ceiling height, but I've got restricted hallways and restricted elevators that are really driving the size constraint of what you can get into the room. So there's lots of interesting and, frankly, for me, unexpected problems. I'm used to the traditional, here's a data hall, whatever you need to get in. We've got these huge doors. But people are finding stranded power sort of all over the place. And that's more the name of the game right now is where is power rather than where is space. There's lots of open fields, but they don't have, megawatts of power hanging out in the open field. So pretty fun dynamic at the moment. And I think we've got solutions for all of the ones that I've heard of so far, but likely more to come up over time, of course.
Yeah, absolutely. And so to round us off, how do you see rack level containment and its adoption evolving over the next year?
I think you're going to start to see more people coming out with a similar solution. It's been, I want to say, in the wings. DDC's been doing it for going on 15 years now. And it solved a lot of PUE problems early on, which was great in areas where power costs were very high. But over time, with the AI boom, obviously, and densities driven up, it made a huge difference to DDC, and that's not going to really change much over the next 3 to 5. Power densities are going to increase. People are going to find new ways to build out where there's stranded power, which we were talking about just a second ago, and some different buildings. Then possibly the other shift will be to the inference side, where you start to see just a handful of cabinets. So it's not a traditional data center. It's, a hospital needs to put in 3 cabinets that are very high density, and they don't need a data hall. They don't need cracks and craws. They just can use a rack level containment solution, push it into, I don't want to say a corner, but essentially a closet, and be able to cool something that's 50 to 100 kilowatts, 3 to 5 cabinets without a lot of trouble. I see that coming. So far, we're not seeing it be pushed out down to like the very low density, or the low number of compute units. But I anticipate it over time. I think all of our executive leadership also anticipates that. So we'll see where it takes us.
Yeah, absolutely, we will. No, thank you so much for joining me on this DC talk today, Tom. It's been a pleasure speaking with you, and we look forward to seeing what you and the team at DDC Solutions are up to. But thanks so much for joining me today.
Yeah, likewise, Emma. Thanks so much for the call. Appreciate talking to you, and we'll see you again soon.
Thanks very much.